Hello, this is Mrs. Spy, and this will be the 5th video on the Unit 1 functions on function composition, the first main lesson of Algebra 2. Let's go to the slides and begin. Okay, so function composition. Okay, so first of all, function composition is when a complete function is substituted into another function. The notation is f parentheses g of x inside f close parentheses, or f. The symbol is read as of g of x, and it looks like a weird little circle. That's why I'm being very careful not to use the dot like we use in multiplication. It's not the same thing. Let's do an example of what function composition is. So let's do the first example using a table to get the idea across. So you always work from the inside out. So let's say you have f of g of 2. So you first go to the table and find g of 2. So g of 2 will be 4. And you take that 4 and you put it inside f. So f of 4 equals 2. So your final answer to the first one is 2. Let's try another one. You first find h at 3. So h of 3 is 4. Then you put 4 inside g, and g of 4 will be 3. Okay, they can also say use the same function twice. So h of 1. So you first put 1 in h. So h of 1 is 3. And you find h of 3, which is 4. And they can make it really complicated with nesting the compositions. Would mean you have a composition inside a composition inside a composition. So you start from the most inner, which would be g of 4, which equals 1. Then we put that inside f. So f of 1 is 4. And we put that, sorry, g of 4 is 3. Oops, didn't catch that. Sorry, I used the wrong function for a minute. G of 4 is 3. Then you put that 3 inside f. And f of 3 is 2. And then you take that 2 and put it inside h. So h of 2 will give you a final answer of 3. So you sort of use this chain to go through all the functions in a row. And that will be your answer. So your answer to the first one is 2. This one is 3. This one is 4. This one is 3. That's how function composition works for the table. That's the basic case. You go from one to the other, the most inner to the outer. And we'll go on to another type in the next slide. Copy down what you need to. I'll continue in a moment. Okay, on to the next one. Let's say we did it with an equation. So you first put the number into the first equation. So first you put negative 4 into g. So g of negative 4 is 3 times negative 4 squared, which would be negative 4 squared, which is 16. 16 times 3, which is 48. So that would be 48. And you put that 48 inside f. So f at 48 is 2 times 48 plus 5. And 2 times 48 is 96. 96 plus 5 is 101. So the answer to the first example is 101. In the second example, we're putting f inside g. So you first find f at 2. So that would be 2 times 2 plus 5, which is 4 plus 5, which is 9. Then you put that 9 inside g. So that would be 3 times 9 squared, which is 9 squared is 81. 81 times 3 is 243. Okay. Copy down what you need to, and go on to the next slide. Okay. Same thing, but here with a few more points and using the other notation. So you first g of 8. We're using the same function g twice. So you first put negative 8 in g, so that would be 3 times negative 8 squared. So g of negative 8. Let's split it up, rewrite that. So you first find g of negative 8 equals 3 times negative 8 squared. This would be negative 8 squared is 64. 64 times 3 is 192. Now you take g of 192. It should be 3 times 192 to the second power. 192 to the second power is 36,864. Multiply that by 3. So that's 110,592. Big number, but it's okay. Now we want to find f of 10. So we first find f of 10. So we 2 times 10 plus 5 should be 25. Then you take that 25, put it inside f again. It should be 2 times 25 plus 5 should be 2 times 25 is 50. 50 plus 5 is 55. Okay. Same thing, but now with 3 functions, and we want to plug this number 4 first into g, then into h, then into f finally. So you first find g at 4. Should be 3 times 4 to the second power. Should be 16 times 3, which is 48. Now you take that 48 and put it inside h. So h of 48 is 3 times 48 minus 8. So 3 times 48 is 144. Take away 8 is 136. Now you want to find f at 136. So you do 2 times 136 plus 5 you get 272. Add 5 to that, you get 277, which is your final result. Copy down anything you need to, and we'll go on to where they don't give you value for x, and they ask you to compose using an equation. Okay. Once in a while, they won't give you the value of x. And you've got to physically take the other equation and put it inside. So in this case, first case, you want to put g inside f. So we're going to put g inside f. So g is 3x squared. We're putting that in for the x in f of x. And then you 2 times 3x squared plus 5, which should be 6x squared plus 5. In the second one, we're going to put g in f inside g this time. So wherever we see that, we'll put it inside. So this would equal to 2 times, sorry, not 2, 3. Not 2, 3 times 2x plus 5 squared. Wherever the x was, I replaced it with f and use multiplication to work it out. So it'll be 2x squared plus 5 times 2x plus 5 times 2x plus 5, which is 4x squared plus 10x, which is 20x plus 25. The way I got that was 2x plus 5 squared equals 2x plus 5 times 2x plus 5, which is 2x times 2x is 4x, plus 10x, because 5 times 2x twice, and 5 times 5, which is 25. Finish simplifying, that'll be 12x squared plus 60x plus 75. I'm going to clear the screen before I do the last two, but that's this basic idea. You put in the first one G inside F, and the second one you put F inside G and simplify. Okay, so let's look at the second two. Okay, what about f of x? Means you want to put f physically inside f. So we have 2 times 2x plus 5 plus 5. Then you distribute the 2, so it's 2 times 2x is 4x plus 10 plus 5, and that becomes 4x plus 15. We physically put f inside f. I'm going to do the same thing in G. Put G inside G. So it'll be 3 times 3x squared squared. Now let's do this one carefully, the simplification. So 3 squared is 9. Squared squared becomes x to the 4th power, and that becomes 27x to the 4th power. So just make sure to separate my answers. Okay. And that's when you put the same function inside the same function. You just replace, you put G physically inside G and simplify. Put F physically inside F and simplify. You don't always have to simplify these questions, but it's a good practice to do it. Remember, power to a power, you multiply. Okay, on to the next question. Composition with graphs. Now, composition with graphs, students find to be the hardest. And you have to do this slowly. So you put your number into the equation. So the line is g of x, and the absolute value function is f of x. Okay, so this is f, and this is g. Okay, so we first find, in the first one, f of g is 0. So we first find g of 0. So you go to your graph, look at 0, and go down 1. So g of 0 is negative 1. And you do the same thing. You find f of negative 1. F of negative 1 would be 6. So the answer to the first one would be 6. And you do the same thing. Here, this time you put 2 in for f. So you first find f of 2. Go over to the absolute value function at 2. Go up to 4. You get 4. Then you find g at 4. Once you're at 4, you go down all the way to negative 5. G at 4 is negative 5. Okay? For the first two, you start with one function, go to the other one. Start with one function, go to the other one. Be very careful. Like when you're at 0, in this case, you're going down to negative 1. Then once you're at negative 1, you're over here, you go straight up to 6, this point right here. In the second one, you're starting on the line. So at 2, f of 2 is actually, wait a minute, f of 2 is 3. Ooh, be careful, I'm going to mess with the graph. Be careful. F of 2 was not 4, but it was 3. Didn't notice it was below the line. Made a mistake there. F of 2 was 3, and g of 3 is negative 4. Oops. Okay, good thing to check over your answers, because I would have made that mistake. It's always good to make sure your answers are right with the graph. Didn't catch that. So So at 2, up to 3, and you go from 3 down to -4. Okay? How about you want to plug into the same function twice? So you first find f of -3. So at -3, our graph is, so at 3, our graph is 8. Then you find f at 8. Should be all the way up here at 9. Same thing with the line. You first find g of -7. So at -7, we're going to be at 6. And then we find g of 6. So we go down here to -7. So using the graphs, students find the hardest. And if you want me to make a separate video just finding functions using graphs, which is the hardest case, leave me likes below, leave me comments below, and I'll make a video just going over how to find composition using a graph, just how to find composition using an equation. This one video can be broken up into many smaller videos. Let's continue. Now, one example where they could ask you to use multiple representations in one. So here, we want to start with the table, and then go to the graph, and then go to the equation. So if we start from the inside out, so we first find h at 3. So that's the table. So h of 3 is 4. Then we take that 4 and we plug it into our graph. So g of 4 is right here at 0. Then we take that 0 and put it inside our function. So f at 0 is 0 to the third power plus 2. 0 to the third power is 0. 0 plus 2 is 2. So this whole thing equals 2. That's as hard as they get in Algebra 2. So if you think you would like separate videos on graphing, function composition, or algebraic function composition where you plug a function into a function, please put comments below and I'll make those videos separately. Let's go on to the next slide. Okay, so that was this. The next video, we'll go over what a one-to-one function is, or also known as an injective function. This lesson that we just went through was based on a 3-day lesson, lesson 6, 7, and 8 of full 2020 lessons that I'm giving. I hope that was helpful. I hope this helps you understand function composition, and come back again tomorrow or later today to see the video on one-to-one functions. Subscribe to my channel, like the section below, and if you really do want me to make more videos on graphing and composition, please put comments below and I'll make more videos on this topic. Hope this helps you out. Come back again for the next video. This is Mr. Spy signing off.